In this video, we are going to review how you solve a quadratic. Notice I've got the word solve highlighted here for you, because the first thing we need to understand is what does it mean to solve. If I've been asked to solve a quadratic, that means I need to get it down to x is equal to some sort of number. This is not factoring. I don't want my answer to be a factor. I want my answer to be a number. And so there are basically a couple of steps. First, I need to factor, and then I need to set the factors equal to 0. The only way I can factor is if my equation is equal to 0. So I do want to make sure that my equation is equal to 0 first. Then I factor, then I set my factors equal to 0. In all of these examples, we will already have our equation set equal to 0. The problems will also already be factored. I've gone ahead and factored these. These problems are from previous videos, so you can go back to those videos if you want to see how this is factored. But I looked for my product and my sum, came up with the factors, and now I am ready to solve. So the last step is to set the factors equal to 0. So I take this factor, x plus 3, and I set it equal to 0. And at this point, I should solve this like we did the very first week of Algebra 1, where we subtracted 3 from both sides to get x by itself, and x would equal -3. We would do the same with the second factor. X plus 8 equals 0. So now I need to move the 8. If it's a positive 8, I subtract 8 from both sides. That gives me x equals -8. And then I need to think about how I'm going to write my answer. Most of the time, an answer for a solving problem is written in brackets, and I put the two possibilities, -3, -8. If you are quick with your math, you may not need to do this step. You can automatically go from x plus 3 to x equals -3 because you understand that moving the 3 is going to change its sign. So some students can go from here to their answer pretty quickly. I've got 3 more examples from the different videos just to look at what different kinds of factors look like and how we get the solution from them. So you'll notice in this example, we have 4x squared minus 81, and that should give me 2x minus 9, 2x plus 9. So I have 2 factors. I need to set each factor equal to 0. This one is not so easy to see in my head, so I'm going to go through the motions. Here's my equal sign. X is what I want by itself. I start by adding 9 to the other side. That'll give me 2x is equal to 9, and then I need to divide both sides by 2. So one of my solutions is a positive 9/2. The other solution, 2x plus 9 equals 0, I will have to subtract 9 first. That'll give me 2x equals -9. And then I divide both sides by 2. My second solution is -9/2. With this one, I had a greatest common factor of t. The t came outside. If the t is outside, it's still considered a factor. So this factor needs to be set equal to 0. There's nothing that we need to do to solve that. We just know that one possibility is that t is 0. The other factor, 4t minus 3, equals 0. We add 3, 4t is 3, and then we divide both sides by 4. T is 3/4. So we have 0 and 3/4 as solutions to that example. My last one is a slip and slide problem. When you slip and slide, you're going to get 2x plus 1 and 2x plus 11. Again, we're setting our factors equal to 0. So each factor is set equal to 0, and then we need to solve. And how much work you have to do here just depends on your level of ability. You might need to go through all the steps that we used at the beginning of the year still, and that's fine. It's better to do all the steps and get it right. So I subtracted 1. That gave me 2x equals -1, and then I divided by 2. So one of my solutions is -1/2. The other solution, subtract 11 from both sides. 2x would then equal negative 11, then divide both sides by 2. Once I do that, I have negative 11 halves as my other solution. Now, we aren't always going to ask for solutions from an equation perspective. What if you have a graph? Well, that's very simple. If I have a graph, then I'm going to look for the x-intercepts. The x-intercepts are the same thing as the solutions. They will give us our solutions. They're also known as the zeros of the function or the roots of the function. All of these mean to look at the same place on the graph. Look at the x-intercept. So in this first graph, I can see that I have an x-intercept at 1, 0, and at 5, 0. If those are my intercepts, then my solutions are 1 and 5. They're the x values of my intercepts. So my solutions would be 1 and 5 for this particular graph. On this graph, my x-intercepts are at negative 3, 0, and at 2, 0. So I know my solutions are at negative 3 and positive 2. I'm using the brackets to indicate my solution because this is not an ordered pair. These are just the x values of the x-intercepts. So my x-intercepts will give me my solutions, and we can call them zeros and roots as well. It's very simple to look at the graph, look for where it crosses the x-axis, and then we know what the solutions are.